Hello. So I'm going to be here to talk to you about designing for security, which is quite novel. So I was doing some research for this talk just the other day, and I realized something. I don't think I've ever seen a security talk at a design conference. Like, I've seen a lot of design talks at security conferences, but not the other way around. And I'm not sure why. I have no idea why we might not be keen to hang out with the security crowd. I mean, they seem like a perfectly friendly, nice, and approachable bunch. My mate Steve. And regardless of how security... This is one of my favorite gifts, by the way. Can you just marvel at how great this is? Regardless of how security experts are portrayed in the news or Hollywood or stock images or at your local Harvey Norman, I think there's one thing that we all have in common and we can all agree on. And that's that the internet owns our lives now. Every part of our lives, from our friends and our family, our most inane thoughts, our work, our hobbies, our sleep, even like our bodily functions are on some app, on some website. It's on someone's computer somewhere. And just like how cars will come with locks and, blenders come with lids, we need to think about how we protect our users or friends. But there's just one problem. Unless you've just been hacked, like yesterday, or you just marathoned all of Mr. Robot and you're like feeling a bit weird about life, you don't care about security. Now, this is something that's a lot harder for my security friends to hear, because obviously they care about it very much. But I think in a room of designers, we can all agree with the sentiment. No one cares about security because people just care about the task at hand. And it makes sense. We currently present security as like secondary actions. And people don't want to be assigned extra homework. Like, no one goes to download your app or signs up for your website just so they can curl up on the couch one evening and spend a nice night just configuring their security settings. And it makes sense, right? Like, what happens when you're on the web and you see a screen like this? Connection is untrusted. Oh, but I just wanted to read memes. Okay, that's all right. I am an adult and I understand the risks. I can proceed anyway. What happens when you're testing out your website and you see this? Oh, crap, I can't get to my website. Don't worry about it though. I am an adult and I know how to do things. I know that all I have to do is press advanced, go proceed anyway, and I'm done. No one cares about security. This is an actual support article from a real-life hosting service that tells people how to get around their own security warnings. This is real. So one day a friend of mine who works in tech is just looking real down, and I'm like, hey man, what's up? And he goes, this client of mine is trying really hard, so very hard, to install a virus on his work computer. I think it was like some printing application, I don't know. But the point is, people don't care. And it's easy when we work in tech to look at these situations where people are willfully ignoring the red warnings in front of them and say, they're being silly. Like, we're telling them this is bad, and they're ignoring it. This is silly. But we all do this from time to time. And blaming our users, our friends, for being foolish is unhelpful. In fact, it's lazy. It's laziness on our part, pure and simple. They wanted to get something done, and we have failed to allow them to do it in a secure and easy way. And that's on us as people building these products, not on them. So why design and security? A lot of the times, UX needs and security needs seem to butt heads a lot. Like, we want less pop-ups and security warnings, not more. And this is the pervasive assumption that we all have, is that improving security necessarily degrades usability. And conversely, if we make something more usable, it inherently makes it less secure. But by the end of this talk, I hope to convince you that this kind of mutual exclusivity, is untrue. And in fact, the opposite is true. Good user experience design and good security cannot exist without the other. Think about it. A secure system is controllable, it's reliable, and hence it's usable. A usable system reduces confusion, thus making it more likely to be secure. Our two fields are inherently interlinked, even though sometimes it feels like they're opposing forces. I drew this in Keynote, I'm very proud. And by working together, we elevate the possible solutions in both our fields. In our product teams, security is usually an afterthought, tacked on right at the end of the development process, if it's there at all. But without considerations about security from the start and throughout the process, small problems can compound to become really, really big ones. Now, I'm not saying that we as designers should suddenly become security experts overnight, but we should at least care enough to know how to spot the warning signs. And it's have you ever been a part of a project where you're brought on 2 weeks from the release date, right at the end of the project, and they're like, can you make this usable for us? And you're like, no. Asked me a month ago. It's the same for security. The considerations have to be made at the start. And it's fine that no one cares about security, because really they shouldn't have to, because we should have to. It's our job to provide safe, accessible, performant experiences. That's the baseline requirement for everything we do. It's our job to care. And as much as I love thinking about how to make an experience delightful and how to make it disruptive, I feel like it's easy as us as designers to get a bit too caught up in that when we forget that all people really want to do is send a freaking email without their identities being stolen. Yikes. So if security is not at the front of mind for everyone, then large structural changes to companies or even individuals are going to be difficult. We need to empower ourselves through education. We need to push for small, long-lasting, habitual change, and we desperately need better security heuristics. I don't know about you, but I know I've still got security heuristics from 10 years ago. Has anyone ever been told to always change your passwords repeatedly? Yeah. Have you worked at an office where you're made to change your password repeatedly? And you know what happens? People write their password on a piece of paper and they stick it to their computer. Classic. This is where we, as designers, can help our more technical coworkers. We know that perfect is the enemy of the good. We can design for outcomes, what's likely to actually happen, rather than all the little technical possibilities of what could happen. And in the security industry, it's common for us to build up a lot of walls, sorry, you can't open that program, or did you want to do a thing? Have you tried not doing the thing? I know you said to run the program, but how about I don't run it? Have you reconsidered all of your life decisions? How about just no? But as we've seen from the certificate warnings earlier, people ignore warnings. Walls don't work. So instead of putting up walls, we can instead carve rivers. We can direct the user in such a way so that the path of least resistance matches the path of most security. So how do we do this? Quick overview for the next 20 minutes. 4-part trilogy. We're going to go through finding intent, the path of least resistance, miscommunications, and mental model matching. We've got a lot to get through, so I'm just going to start. Finding intent. So, as you all know, there's a long-lasting misconception that security opposes the desire to make things easy. However, and I want this to really sink in. Our job is not to make everything easy. Our job is to make a specific task that a specific friend is trying to accomplish at that specific time, in that specific place, easy. The tension between usability and security often occurs when we can't accurately determine what our friends want to do. So if we want to tighten security without sacrificing usability, then it's all about getting more specific about their intent. What are they trying to accomplish at this current time? How do we make the most easy way for them to do that, the most secure way as well? And when it comes to finding intent, we can be clever about this. We don't have to ask them directly every time they do something. We can think about context to infer their intent. What's the time of day? Do we know who they are? Who are they? Where in the app are they? How did they get here? And while it can be tempting to just surface a prompt and actually ask them, don't force prompts if you can help it. Seeing prompts and pop-ups and warnings all the time teaches our friends to learn that security is something that obstructs their work, and it trains them to just dismiss them. The false alarm effect is definitely a thing. Each false alarm reduces the credibility of your app. And there's been heaps of studies done on this. This is an image from one by Anderson et al. What they did was they put participants into fMRI machines, which scanned your brain. Very cool. And they showed them security prompts. It's a fun Tuesday evening. And what they found was only after a few exposures, the participants did less visual processing of the prompts, which is not to say that they read the prompts and then they were like, I don't care. It means that they actually stopped seeing the prompts themselves. So we can infer a lot from proximity and relevance, not aggressively putting up prompts. And we can use our wealth of data to test whether our inferences are correct, improve and repeat. Remember, walls don't work, so we build rivers. And on that topic, let's look at the path of least resistance. The idea here is that users shouldn't have to choose to be less secure, which sounds kind of silly. It's like, why would anyone choose to do something insecurely? But it happens all the time. It's natural for us as humans to be economical with our physical and mental resource. And security isn't what people are thinking about all the time, right? They're thinking about what they want to get done. So therefore, our primary consideration is to keep the user's motivation and our security goals aligned with each other. When these two goals become misaligned, then our friends will subvert our security measures, whether unintentionally or even intentionally. Walls don't work, build rivers. And an interesting thing here to note here is the trivial path, which is what happens when users just don't do anything. Well, if we want doing nothing to be as secure as possible, all the settings in our app should be secure by default. And this can be as simple as defaulting to the no option in a confirmation, or if you want a physical analogy, consider a blender that has a motor that doesn't turn on unless you put the lid on securely. There's no way to screw that up. It's secure by default. Okay, so what happens if your users don't want to do nothing? Well, when it comes to crafting a path of least resistance, let's look at our journey maps. And for each possible task that they might want to do, what path is the most comfortable? What path is the most secure? Can we make the secure one more comfortable? The more comfortable one more secure? Can we merge them at all? And as designers, we know that when we want to craft any kind of path or user map or user journey, their behavior is largely guided by affordances. So that's the visual and interaction cues in your app. So, are your security-relevant interactions discoverable? Or are they buried 4 levels deep in a menu? And when it comes to these settings, it's really important that we communicate the consequences of an action. And if they can't understand the consequences, we shouldn't surface them at all. And it's not enough to just hide them like in a drawer under the advanced setting, because how many times have you seen like Facebook posts floating around telling you to copy and paste random bits of code into your browser to like get cool hacks or get GIFs on Facebook, I don't know. If it's there, people will abuse it. And if your users really need an option, we need to communicate the consequences accurately and clearly. Which brings us to our next part, miscommunication. Whenever there is a miscommunication, there is a human security vulnerability. So here's a question. What are you inadvertently communicating to your users? Take the green secure lock in Chrome, for example. What does this mean? Does anyone want to take a guess? Shout it out. What does this mean? It's all good? Anyone else? People think it means all good. Yeah, people think this means safe. But what this actually means is that your communications with Google are encrypted and that google.com is actually google.com. So this is a miscommunication. It doesn't necessarily mean that you're like all good. It doesn't necessarily mean you're secure, you're safe. So this is a human security vulnerability. And if I got bored one night and I felt like doing some crime, I could open up my laptop, register like a legit sounding name. This one looks pretty good to me. And I could grab a free SSL certificate, thank you very much. And with my elite hacking skills in HTML and CSS, I could build a pretty legit looking scamming website with that green lock that people think means safe. Just to make that clear. Just to make it really clear. And I can do this with any website, not just the largest bank in New Zealand. Maybe I should have chosen like a smaller theoretical target. I could do this with any website. So my point is, do your users know what you're trying to communicate? What is their mental model of what's happening compared to yours? Use this understanding to patch any instances of miscommunication. Because we know that miscommunication is bad for usability in general, but there are also security vulnerabilities. Match your mental models. Which brings us to our fourth part in our design trilogy. When I say matching mental models, I mean matching how we think to how our users think. So as designers, we have an idea of how our product should work, and then we work with our developer friends to build our thing, which then communicates to the user, and then they develop an idea of how it works. So when it comes to security, it can be really easy to get caught up in like the technical hoopla of this part. Fancy hacks, zero-day exploits, guys in hoodies, and balaclavas on the computers, I don't know. But when it comes down to it, what makes a system secure is the parts above. It's oh, hang on. It's embarrassing. What makes a system secure is user expectations. For our apps and our websites to protect our users' interests, our system's behavior should be consistent with their expectations. Think about it, like a man-in-the-middle attack is not necessarily insecure. Telephone is basically a string of man-in-the-middle attacks, but it's not horrible. It's a plain children's game. Man-in-the-middle attacks are bad in a lot of our cases because our friends expect their data to go to an expected party. It's all about their expectations. So here's the definition. A system is secure from a given user's perspective if the set of actions that can happen are bounded by what the user believes that it can do. Therefore, designing secure systems means that we have to understand our users, our friends, their mental models, how they expect things to work, not necessarily how things actually work. So there's two approaches here, and I think the best way is to kind of use both in tandem. We can either find out their mental model and then communicate to that, or we can manage their expectations through our design to better match the system. With matching to the user's mental model, we've gone one step further here. Rather than just inferring their intent, we're starting to think about their entire model of how they think our system works. Now, I know I might sound like I'm trying to tell you all to read people's minds, but we don't necessarily have to do that. Take customization, for example. Customization has always been like a nice to have, but I want to put it forward as a usability and therefore security feature. Instead of forcing our customers to interact with our mental model, we allow them to impart their own model onto our system. And this can be as simple as just letting people name things in their own session. Remember how miscommunication equals security vulnerabilities? Well, this removes it, just like that. What am I doing? Oh, this is the next part. We can also influence the user's mental model through our designs, through what we communicate to them. And any communication that helps clarify your interface without causing further confusion is good. For example, take this lovely, beautiful sign-in button. Putting a lock on your sign-in button does nothing to actually make your flow more secure. But it can be important if we want to communicate the appropriate boundaries of our app to our user. This section is behind auth, this section is not. This section everyone can see, this section is only for you. Making our friends feel the correct level of security that they're actually in is really important as well. It builds trust between your app and your users, and without trust, your users will start to question the validity of every step in your process. And sometimes that leads them to just circumventing your security measures altogether. And it's not just about communication. We can also look at our paths of least resistance and use it as a teaching tool. This is something I think we can forget sometimes, is that when we design, we teach. When we make products that work a certain way, we're also teaching our users to behave a certain way. We're influencing their mental model with ours. So here's a question. How are we already doing this? For example, take Apple. I'm sure everyone will be aware of the pop-up that always comes up telling you to sign in to your iTunes store and you just put your password in because you want it to go away. And that's fair. They want to confirm that you are who you say you are. But every time you fill this in, they're training you to put in your password without thinking. And they might not intend to train you like that, but that's what's happening every time you put it in. This pop-up is an official iOS pop-up. This one is fake. Would you have caught that? I would not have. I would have just mindlessly put my password in. So what are we teaching our users to do? How are we influencing their mental models? When it comes to designing for security, knowing and understanding how different mental models interact with our product and our users is the key. It's all about finding, influencing, and matching these mental models. I have a thing. Is it secure? Well, that's a meaningless question to ask without specifying who it's secure for, what they're trying to accomplish, what are their expectations. And this is why good, reliable, secure systems is really difficult. Because managing expectations through visual cues and interaction cues is really difficult. But that's our bread and butter. That's what we're here for. So what are your users' mental models? Seek to understand their models of your application and speak to that model rather than the detailed ins and outs of what you understand. I'm running out of time, so I'm just going to skip this bit. In summary, here are some takeaways that I hope will be helpful. Cross-pollination between us, the design community, and the security community is rare, if at all. And it's a massive missed opportunity. We could come up with so much better solutions for our friends if we just got along a bit more. And while security isn't the sexiest topic, it's our job to care about it, just like how it's our job to care about accessibility and performance. And it's about aligning our friends' goals to our security goals. And we can do that through finding their intent. We can do that by crafting the path of least resistance to match the path of most security. We can do that by understanding how they model our system and communicating in a way that's sympathetic to that model. Before I leave, I'm going to tell you one final anecdote. On the floors of one of our offices, right next to the door, is this. It's a little switch with a post-it note on it saying, no. Who can guess what I immediately did after I saw this? Walls don't work. Build rivers. Thanks.